Welcome back to another lesson on trigonometry. We will continue our discussion today with trigonomic identities. The identities are very important. You'll see them a lot if you do trigonometry course. Let us begin with the Pythagorean identity. This is angle theta. Remember, this is x, this is y, and we've defined the hypotenuse to be equal to 1. So by Pythagorean theorem, x squared plus y squared is equal to 1. Now remember, y is sine theta, x is cosine theta. So it follows quite naturally that cosine squared of theta plus sine squared of theta is equal to 1. Now if we divide each term by cosine squared, this is going to be 1. Sine over cosine is tangent, so we're going to get tangent squared of theta. And 1 over cosine is equal to secant, so 1 over cosine squared is going to be secant squared of theta. Let's call this equation 1. This is going to be 1 divided by cosine squared of theta. Gives me that. Equation 1 divided by sine squared of theta gives me what? Cosine over sine is cotangent. So we're going to have cotangent squared plus sine divided by itself is 1. And 1 over sine is cosecant. These three called the Pythagorean identities. Very important. Let's redraw our unit circle. Here's my unit circle. Now if I divide it into the 4 quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. If I have my triangle, my right triangle of angle theta, what if I were to draw a line straight across here and I have another triangle? Well, notice, right, the height is the same. Turns out this angle is the same. Now the height is y. Y is sine theta. Sine of, what is this angle? I should note that we normally define angles from the positive x-axis going counterclockwise. So this is going to be, if this is theta, then this angle is going to be 180 degrees minus theta. 180 degrees is also equal to pi radians. Sine of pi minus theta is equal to sine theta. Okay, now if we do the cosine, well, the length is the same, but it's now on the negative side. So cosine of pi minus theta is equal to negative cosine theta. So we went from the first quadrant to the second quadrant. What if we go from the first quadrant to the fourth quadrant? So now I have a minus theta. Well, here, okay, cosine is the same. So we're going to have cosine of negative theta is equal to cosine theta. And sine, okay, so again, this height is going to be the same here and here, but it's now on the negative side. So the sine of negative theta is equal to negative sine theta. Okay, we'll revisit these guys later when we graph sine and cosine. This is what we call an even function. This is an example of an odd function. So that'll come back. Remember from our triangle, what's this angle here? This is 90 degrees. So this is going to be 90 minus theta. 90 degrees. Or, remember in radians, that's pi over 2. minus theta is that angle. So if sine theta is opposite over hypotenuse, okay, sine theta, well, that's going to be the cosine adjacent over hypotenuse of this angle. So sine theta is equal to cosine of pi over 2 minus theta. Likewise with cosine. The cosine of theta is adjacent over hypotenuse, but if we're referencing this angle, that's now the opposite over hypotenuse, which is sine. So cosine theta is sine of pi over 2 minus theta. Okay, so we have our Pythagorean identities, our even-odd identities, and a couple other important identities involving what later we can call a phase shift. That sets us up with the basics. Stick around for some more identities and applications of them.